1 is finding a constant rate of change, so that's nothing different than what we did in section 8-4, right? So it's just finding the rate of change, so you're looking for 2 points. So, if I look at my graph, easy, obvious point that I want to use is 0, 0, because it's easy. Another good one to use is really any other point as long as it's an exact point. You want to use pretty points, don't use things that are in the middle. But say, for instance, I could use that point right there for 30. So then I need to do the difference in my y values, which my y values, the high y value would be 30, and the small y value would be 0, right? Over the difference in my x values. My x value at my second point is 4, and the x value at my first point is 0. So I get 30 divided by 4, which gives me what? 7.5. So 7.5 is my constant rate of change. It doesn't matter which 2 points you pick. You didn't have to use 4, 30, and 0, 0. You could have used any other points. Who used different points than those? Did everybody get 7.5?
Yes.
Okay. So it doesn't matter because it's a constant rate of change. Any point along those lines is going to have that same rate of change. So any 2 points on it, you'll get the same value unless you mess up on your math, right? Now, the second part of this question, though, which is important, you can't just find it. It says, and interpret its meaning. That's important. What does 7.5 being our rate of change mean? No one? All right. Okay, right. That means that the price is going to go up by $7.50, or the profits off the fundraiser, I should say, is going to go up by $7.50 for each car that we wash, right? So that's what a constant rate of change which means that they're charging every person $7.50 to wash a car, right? If we did a similar graph, you could have vehicles washed and your profit could be different if, say they charged a different amount, whether it was an SUV versus, a compact car, or, something like that. So you could have a nonlinear equation that represents a car wash fundraiser based on if it wasn't a constant rate of change. But this one's constant, meaning it's the same price for each car, no matter what kind of car, $7.50, right? So that's what interpreting is. It's saying, okay, that means each car is $7.50 added to the fundraiser. All right, if we look at our second one, now this one is a table. Still need to find constant rate of change, which means I can use any 2 points, right? Because it's constant rate of change. So the difference between 3.610 and 4.6 or 4.812 would be the same as the difference between 1.26 and 3.610, right? So it doesn't matter which 2 points. So I'm going to do this value minus that value. So my y value is going to be 12 minus 8, right? That's the difference in the y values. And my x value is going to be 4 8/10 minus 2 4/10. So 12 minus 8 gives me 4, and 4.8 minus 2.4 gives me 2.4. And then 4 divided by 2.4 gives me 1.6 repeating, right? So, what does that mean if I interpret that? 1.6 is a distance, right? Compare our y values is 1.6 compared to the time, which if we're finding this, it's per 1. Remember, that's what we're looking at. When we're looking at a rate of change, we're looking at what's happening to y for each change in x. So for each 1x, for each 1 second, right, we're covering 1.6 repeating yards, right? So that's what interpreting it would look like. Now, let's go on to the later questions because they're a little bit more difficult. All right. Determine whether a proportional relationship exists between the two quantities shown in each of the functions. Explain your reasoning. All right. Proportional relationship means simply, does it show direct variation? So look at the first one. How can is number 1 direct variation, yes or no? Yes. How do I know that?
Oh, because if you plug it into the equation, it works. You like 7.5 times 2 will be 7.5 times 4.
Okay, right, because the difference between the relationship between x and y is always the same, and it's always just a constant times. There's a really easy way that we talked about in class yesterday, though, that you can see it on this graph, that it's direct variation. Does anyone remember what's the easy thing that you can see that lets you know this is direct variation?
Like, you do, like, match it up a bit times, like,
Easy thing. Luke?
it's a straight line.
Well, that just means it has a constant rate of change. Thomas? There we go. Remember, if it's a direct variation equation, it's going to pass through the origin. The origin is 0, 0, right?
Yeah.
Direct variation equation looks like y equals k times x, where k is anything other than 0, right? So if I make a t-table for any direct variation equation, any equation that has this format, y equals a constant times x, if I let x be 0, what's y going to be? 0, right? Because k times 0 is 0. It doesn't matter what k is. K could be negative, it could be positive, it could be a fraction, it could be a decimal, okay? But if you multiply it times 0, you're going to get 0. So every single proportional linear relationship, everyone that has direct variation is going to pass through the origin. So a very, very simple way to look at a graph and say whether or not it's direct variation, does it go through the origin? If it doesn't, not direct variation. If it does, it is. All right. Now, the second one is a table, so it's not quite so easy. So how can I tell whether the second one is direct variation or not? I hear crickets. Anyone else? Okay. Well, it doesn't. If it had 0 on here, on the table, and the y value was something other than 0, then that guarantees to you that it is not direct variation. And if it has 0, 0, then it is. But if it doesn't actually show what the y value is when x is 0, we can't go off of that because you don't know. Maybe if it had 0, it'd be 0, 0. Maybe if it had 0, it'd be 0, 2. So if we don't actually have 0 something on our chart, we can't go by just that. So what do we know about a direct variation equation? Y equals something times x, and it's the same something for each one. So that means that the y value 6 should equal some constant times 1.2, right? And the y value 8 should equal that same constant times 2.4, and the y value 10 should equal that same constant times 3.6, right? So what I can do very simply is I can say, okay, 1.2 times k should equal 6, right? Y, that's my y value, equals the x value times some constant, right? So to find out what k is, I would do 6 divided by 1.2, which gives me 5, right? Everyone with me so far? Yes, Brush?
I wrote, if you multiply the answer by
Yeah.
If you multiply what now?
so number one, if you multiplied 7.5 by x, it will equal to y.
Okay, you're still talking about number 1?
I'm just,
Okay, we're talking about number 2 now. So for number 2, we have the relationship between x and y for the first value is that x value 1.2 times 5 equals 6, right? Yes? So the question is, does 2.4 times 5 also equal 8? If I do 2.4, which is my next x value, times 5, does that equal 8? No, it doesn't. Okay? 2.4 times 5 gives me 12. So if I just plug in that same constant, remember that the idea is if it is direct variation, if it's a proportional relationship, then you should be able to use the same value, multiply every single x value by the same constant, and get every single y value on that chart, right? And if the first value has to be multiplied by 5 to get 6, and if I multiply the second value times 5, I get 12, not 8. So that right there tells me it's not going to be direct variation. So all you have to do is find what the constant would be. What's the relationship between the first values? See if the second values have that same relationship. If they don't, then it's not proportional. It doesn't have direct variation. All right. Let's move on then. The next question says the cost of paper varies directly with the number of reams bought. Okay, if it varies directly, what does that mean to us?
You said, direct variation?
It's a direct variation equation, which means y equals some constant times x, right? Yes? All right. Suppose 2 reams cost $5.10. 2 reams is going to be my x value. 5/10 is going to be my y value. So $5.10 is equal to 2k, right? This is how we find what that constant of direct variation is. We know the relationship between our y's and x is going to be the same thing. In other words, every ream of paper is going to cost the same amount. You don't have, some that are the, super ply reams of paper that cost more, or, they're all the same price. That's what this means. It's direct variation. It directly varies. There's no discount for buying in bulk. If you buy 20 reams of paper, then it's going to cost you the same price per ream of paper as it does if you just buy one, right? So it varies directly. And then by plugging into our equation, our y value is 5/10, our x value is 2. Now I can solve to find out what my k value is. So I'm going to divide by 2, and 5/10 divided by 2 is... Right. So my k value, if I divide through by 2 on both sides, my k value is going to be 2.55. In other words, each ream of paper costs $2.55, right? Now, The question, though, asks us to find an equation. Now I know what k is. My direct variation equation looks like y equals k times x. So y equals 2.55 times x. So our first step is we have a specific x and y value that works, right? Then that tells us what's the relationship between x and y. The relationship between x and y, the relationship between the number of reams of paper we have and the price is 255 times the number of reams gives us our price, right? And then that's our equation. 255 times however many reams of paper we have gives us our price, which is y. Then, once you have your direct variation equation, now the cost of 15 reams of paper means you're going to let x be 15. Oh, yeah, would you go, oh, actually it might, oh, it's reconnecting, hang on. Sorry, guys. All right. Okay, so 15 reams of paper means x is going to be 15, so now you just plug into the equation. And this is a big part of what you'll be doing in math as you get into algebra more, is writing an equation and then plugging in a specific value and finding out what y is at that specific value. That's a big thing that you'll be doing more and more. So my y is going to equal $2.55 times 15 reams of paper, so 255 times 15 gives me $38.25. So that would be the cost of 15 reams. Everyone follow that? Okay. So the next one, we're looking at a length of spring that stretches, which varies directly with the amount of weight attached to it. Spring problems are also a big favorite with like physics when you take that class, okay? Because springs do have a relationship between how much they stretch and how much weight's on them. You know, the more weight you put on it, the more it stretches, okay? Now, if it varies directly, again, that means it's going to look like y equals k times x, and they're giving us a specific x and y. They say it stretches 5 centimeters when 10 grams of weight is attached. Which is my x and which is my y? Which one depends on the other?
The weight depends on the weight. Yeah, the weight. The length depends on the weight.
Okay, the length depends on the weight. The more weight I put on it, the more it stretches, right? The less weight. What we control is how much weight we put on the spring, right? The relationship then is what happens to the length of the spring as we change the weight, right? So, oh, no. So, if we have a spring and it is a 10 gram weight, that's our x. So we have 5 equals 10 times k, right? The weight of it times that constant should equal the length of it, right? So if I find k, I just divide through by 10, and my k value is going to be 5 over 10, which is 1/2 if I simplify it, right? Or 0.5, but I prefer fraction form. So my constant is going to be 1/2, so then to write my equation, I just write y equals 1/2 times x. Once I find k, it's really easy to plug in. Y always equals k times x. So y equals 1/2 times x is my equation. And then it says estimate the stretch of the spring when it has 42 grams of weight attached. So that means we're going to let x be 42. So I have 1/2 times 42. And of course, half of 42 is 21. So we would expect it to be 21 centimeters long if it has 42 grams of weight attached to it, right? All right. So, like I said, if you didn't get it and you didn't have it done, do the skills practice tonight. And then I'm going to hand out the practice test for you to work on as well.